Hello everyone, welcome to the video. Today I'm showing you how to use the 74HC595 shift register with the 8-segment display using the Arduino. So in this video we will be building a project where the 8-segment display will be counting starting with 1 and then counting all the way up to 9 and then starting over. So basically we're going to be doing that in this tutorial, so without further ado, let's get started. Okay, so now I'm going to go ahead and set up the circuit. So now here is the shift register. So I'm going to go ahead and put it on the breadboard, like so. Okay, so first we're going to go ahead and connect up the power pin. So we're going to connect G and D, which is pin 8 on the shift register. And if you want to see all these pins and what they're called, I have a diagram right here, and you can look at that. And also, if you want to know more about the shift register, I have a video in the description to a tutorial that is all about this shift register. And then the next pin is VCC. That would be going to positive 5 volts on the breadboard. There we go. And it's this pin 16 that we just connected. Now I'm going to go ahead and connect the negative rail, which is right here, to this negative rail over here. There we go. So now both these negative rails are connected. So now I'm going to go ahead and connect pin 10 on the shift register to positive 5 volts on the breadboard. There we go. Then we're going to go ahead and connect pin 13 on the shift register to ground on the breadboard. Okay, so now I'm going to go ahead and connect up the 8-segment display. So we're going to put it right there. And I'm going to go ahead and connect one of the COM pins on the 8-segment display to the ground rail on the breadboard. There we go. And then I'm going to go ahead and connect all of the LEDs on the 8-segment display to their resistors. Okay, there we go. All the resistors are all connected up. And so now I'm going to go ahead and connect all of these resistors to their proper pin, output pin on the shift register. And so now the first thing we're going to connect is the C LED on the 8-segment display to pin 15 on the shift register, which is, it's the output pin 0. So it's the first output pin on the shift register. And then LED D will be going to pin 1 on the shift register, or also known as output 2. And then the E LED on the 8-segment display will be going to pin 2 on the 8-segment display, which is also known as output 3. And also I have to say, by the way, is that these resistors, these are 330 ohm resistors. You could choose any resistors in between 200 ohms up to 470 ohms. And then LED B on the 8-segment display will be going to pin 3, also known as output 4 on the shift register. And then LED A on the 8-segment display will be going to pin 4 on the shift register, also known as output 5. And then LED F on the 8-segment display will be going to pin 5 on the shift register, also known as output 6. And then LED G will be going to pin 6 on the shift register, also known as output 7. So now we'll go ahead and connect the 8-segment display to the Arduino, which all we need is 3 pins. That's what makes this chip so great, is that we can control 8 LEDs and only have to have 3 pins. So pin 11 on the shift register will be going to pin 12 on the Arduino. And then pin 12 on the shift register will be going to pin 8 on the Arduino. And then pin 14 on the shift register will be going to pin 11 on the Arduino. And then we're going to go ahead and connect the 5V pin to the positive rail on the breadboard. And then the G and D pin on the Arduino will be connected to the ground rail on the breadboard. And so basically that is the circuit. So now we'll go ahead and look at our code. Okay, so now here is the code, and so the first thing we do here is we go ahead and set up the pins. So we have latch pin, that's pin 8, so we put that into this variable, and then 12 we put it into clock pin, and then pin 11 data pin, and then down here we have byte. And so basically this is the very important part here. This is storing all of the binary numbers that each one of our numbers represents. So basically, for example, if you want to display 1, you would give the shift register this binary number right here. This, each one all the way up to 9 right here, has its own binary number, and when we give the shift register this binary number, it will display whatever number you want. If it's 9, you display this binary number. If it's 6, you display this one, and so on for all the others. And so basically, we just hold all of these numbers in this array digits. Okay, so then we go into the void setup and we set latch pin, clock pin, and data pin on outputs. So then we go into the void loop and we just have a full loop in here. And so this full loop, it has num. So right at first, num is going to be equal to 0. That's what we're saying here. And we're going to continue looping this full loop until num is no longer less than or equal to 8. Alright, so for example, if it's 9, then we're not going to come into here because the digits array can't go any higher, or we can't count any higher either. So we're not going to continue going. We're going to get out of this loop and start all over. And so every single time we loop this for loop, we increment num. So each and every time we increase the number that we are counting to. So then we come into the for loop and we do digital write latch pin low. So as you know, whenever we turn latch pin low, that tells the shift register that we want to send data to the shift register. So that's what we do after we turn this pin high, latch pin high, and then we come here and do shift out, and we basically send the information. And that's what we do here. We basically give data pin, so it knows the pin that it's going to be giving the data to the shift register. It knows which pin to give it through, and we give it clock pin, and this is telling us what direction we want to upload the binary number into. If it's which way or another, could be either way. And in this case, we're doing least significant bits first, and so that's what this is here. And then the most important part is we go ahead and give all binary number, which is digits, which is the array where we stored all these binary numbers in, and we say num. And since num is slowly incrementing every single time it comes to this for loop, it's first going to go to the 0 slot, which is here, which is the binary number for 1, and then it's going to increment num again, and then we'll come to this one, and we're going to print this one, and it's going to slowly keep on counting all the way up to 9. So then after we give it its binary number, then we'll go ahead and do digital write latch pin high. We turn the latch pin high, saying that we not send IMO data to the shift register. And we go ahead and wait 1 second so we can see the display slowly counting up to 9. And so basically that is the code. So now we go ahead and look at our project in action. Okay, so now here is the project, and as you can see, the 8-symbolic display is counting all the way up to 9, and then it's going starting back over to 1. You may recognize that 2 is very, very dim. To be honest, I don't really know why. I think it's because of the 8-symbolic display that I have, but overall everything is working properly. And so basically this is the project. If you like this video, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing if you want to see more content like this. Thank you everyone. Have a great day.